All right, got the recording started, so let's jump on in. So tonight we are covering chapter 5. To get more manuals and other resources, go shop online. Tonight we are going to talk about chapter 5, which is modulation and bandwidth. So kind of a review from before. We have a basic radio station with an antenna and a feed line, and get my mouse to work. It goes into a transmit receive switch, and on one side is the receiver and on the other is the transmitter and a power supply. So what happens during radio communication? The transmitting is the sending of a signal, and it's information, a voice, data, video, commands, etc. that is converted to an electronic form, and the information in the electronic form is added to the radio wave. The radio wave carrying the information is then sent from the station antenna into space. What happens during that's the same one, receiving? I hate when they do that.
Were you going to share your screen, Jim?
Oh, yeah, I guess I do need to hit share, don't I?
That would be nice.
Oh, no, it is shared.
It's sharing just fine.
Yeah, you don't see it, Daniel?
Oh, there it is, down there. All right.
Wow.
Got it.
Psych. You're supposed to say psych.
I just seen your pretty face up there. That's what I say.
Psych. Okay, let me put this out of the way. Okay. So now on the receiving side, the radio wave carrying the information is intercepted by the receiving station's antenna. The receiver then extracts the information from the received wave, and the information is then presented to a user in a format that can be understood: sound, picture, words on a computer screen, or the response to a command. Adding and extracting the information can be simple or complex. This makes ham radio fun, learning about how a radio works. Don't be intimidated. You'll be required only to know the basics, but you can learn as much about the art and science of radio as you want, aka general and extra. Adding information, the modulation. When we add some information to the radio wave or the carrier, we modulate the wave. We turn the wave on and off in Morse code. We add speech or music or data. And different modulation techniques vary different properties of the wave to add the information, like the amplitude, frequency, or phase. The phase. Along with frequency and period, another important property of wave is the phase. Phase is a position within a cycle. Phase is also relative position between two waves. CW or Morse code is on and off. And as you see here, when it's on, you have the carrier with the tone, and when it's off, you have a blank spot, and then when it's on longer, you'll have the carrier and the tone in it. Amplitude modulation, or AM. In the AM, the amplitude of the carrier wave is modulated in step with the waveform of the information. Here is the tone. So here you have the audio tone, and it's being mixed in with the carrier to give you a AM signal, which gives you an envelope here. And that's the AM modulation. Composite signals. The process of adding information to an unmodulated radio wave creates additional signals called sidebands. The sidebands and carrier work together to carry the information. The combination of carrier and sidebands create a composite signal bandwidth. The carrier and sidebands have different frequencies, occupy a range of spectrum space. The occupied range is the composite signal's bandwidth. Different types of modulation and information result in different signal bandwidths. The characteristics of voice amplitude modulation. AM signals consist of three components: the carrier, the lower sideband, and the upper sideband. AM bandwidth is twice the information bandwidth. Characteristics of voice information. Sounds that make up voice are a complex mixture of multiple frequencies from 300 to 3000 Hz. Two mirror image sets of sidebands are created, each up to 3000 Hz wide. So here you have the carrier at 800, here you have the upper sideband of voice, and here's the lower sideband of voice. The AM voice signal bandwidth is 2. You got the 2 times 3000 or 6000 Hertz from here to here. Single sideband modulation, or SSB. The two sets of voice sidebands carry duplicate information. We can improve efficiency by transmitting only one sideband and reconstructing the missing carrier in the receiver. Single sideband is only 3000 Hertz for voice signals. So here you see where the lower sideband has been removed and the carrier is being suppressed, so you have your voice in the upper sideband here. Frequency and phase modulation, FM and PM. Instead of varying amplitude, if we use the information to vary the carrier's frequency, frequency modulation is produced. FM bandwidth for voice is between 5 and 15 kilohertz. We can also shift the signal's phase back and forth, creating phase modulation, or PM, that is very similar to FM. So here you have the carrier, the FM carrier, and you have your modulating signal, and when you modulate it, you get it compressed here and stretched out here. Here's a eye chart, a table for the typical signal bandwidths. CW is around 150 Hertz or 0.15 kilohertz. Single sideband digital ranges between 500 and 3000. SSB signals is 2 to 3000. AM voice is 6 kilohertz. AM broadcast is 10 kilohertz. FM voice is 10 to 15 kilohertz, and FM broadcast is 150 kilohertz, and then commercial video is 6 megahertz, with some differences noted down here for below 29 megahertz. Now for some questions. Why should you not set your transmit frequency to be exactly at the edge of an amateur band or subband? You can go ahead and unmute and give a shout out. You don't want to set yourself at the edge of a band because there may be differences in the calibration of the transmitter frequency display, or that the modulation sidebands do not extend, to make sure that they don't extend beyond the band edge, and to allow for transmitter frequency drift. What might be the problem if a repeater user says your transmissions are breaking up in the voice peaks? You're talking too loudly. That'll make your voice peaks garbled.
Jim?
Yeah.
Let's go back to the last question here for a second.
That one?
The last one, yeah. About the band edge.
Oh, the band edge.
Yes. Some of the modes are your dial frequency that you see on your dial is on the bottom end of your band. And sometimes it's on the top edge of your transmitted band because you've got a range of frequencies you're actually transmitting in. So on lower sideband, your dial frequency is the top edge of it. So you're actually transmitting 3,000 cycles below up to your dial frequency. On upper sideband, you're reading the lower side of the band. So you're transmitting between that frequency and 3,000 cycles above that. On AM, you're in the middle. On FM, you're in the middle, so you transmit on both sides of your dial frequency. This is why you don't want to set your dial frequency to the exact edge, so because you may be transmitting out of band. If it's in the middle of the range of frequencies you're transmitting in, you're going to go out of band. So you got to watch what mode you're transmitting in, and that's why you stay away from like 3,000 hertz away from either edge, the lower or the top edge. Go ahead, Jim.
Okay. What type of tones are used to control repeaters linked by the Internet Relay Linking Project, or IRLP protocol? Those are the DTMF. Those are the touch tone sounding tones.
That your phone produces.
Yep. Which of the following is a form of amplitude modulation? And you can't see everything, so the answer is a single sideband. What type of modulation is most commonly used for VHF packet radio transmissions? VHF packet radio transmissions use FM.
Now your dial frequency is in the center of the frequency, so you transmit below that frequency and above that frequency on FM. On sideband, you're on top of the bottom.
Which type of voice modulation is most often used with long distance or weak signal contacts on the VHF and UHF bands?
Single sideband.
Correct.
Yes.
Single sideband.
Either Morse code or single sideband. I don't think Morse code is one of the choices on this, or the four answers you have there.
Well, it says voice modulation, that's why.
Yeah, voice modulation is going to be a sideband then.
Which type of modulation is most commonly used for VHF and UHF voice repeaters? It's FM for VHF and UHF voice repeaters.
Now we talk about repeaters because we have over 430 here in Western Washington. They're free to use, and you can access them with a simple handheld that costs $25 to $50. And we use them quite a bit, our repeaters.
Which sideband is normally used for 10 meter HF VHF and UHF single sideband communications?
Upper sideband,
What was that?
upper sideband,
Correct, upper sideband. What is the primary advantage of single sideband SSB over FM for voice transmissions? SSB signals have a narrower bandwidth. They're down to only about 3 kilohertz. What is the approximate bandwidth of a VHF repeater FM phone signal?
Phone is going to be voice. Sideband is 3, but the FM is going to be 15 kilohertz for 15,000 cycles.
Yep.
That's how wide the river stream is.
So FM voice repeater or VHF repeaters is 10 to 15 kilohertz. What is the typical bandwidth of a Fastcan TV transmissions on a 70 centimeter band? That's going to be bigger.
That's going to take 6 million cycles. Yeah, it's quite very, very wide.
Very
We have
wide.
from 420 to 450, so we have 30 megahertz up there, and we have room to operate there.
Do we have anybody doing?
We actually have a Fastcan analog Fastcan TV repeater up on
Ah,
Cougar Mountain.
ah,
We had a
I'm gonna-
very active group. They sent 20 camera helmets back to Ground Zero in New York after the towers came down. They never got them back. They did get a check for it though. Yeah, we got a very active Fastcan TV group.
I'll have to look at that again. I haven't hunted that one down. What is the approximate maximum bandwidth required to transmit a CW signal?
150.
50 hertz.
150 hertz is correct. What is the approximate bandwidth of a single sideband SSB voice signal?
3 kilohertz.
3 kilohertz is correct.
Sorry, I have a question for the continuous wave one. Like, is it asking
Morse code.
Morse code? So it is asking for the bandwidth, but really, like, it is just transmitting under a signal which is 150 hertz. So it's really just, there is really not much bandwidth. You just need one frequency. Is that?
Well, you're using 150 frequencies, a little small stream of 150 frequencies. That's what you're using. And Jenny, it's a 4-to-1, so that's about 37.5 words per minute.
I think what he's
20 words.
asking, though, I think what he's asking is, you're varying the carrier is what you're doing.
Yeah, it's very narrow, right?
It's the
Yes.
tone of the carrier.
Yeah.
Yes, but it's still actually using more than one frequency. It's using about
Right,
150 frequencies. It's
right.
a real narrow. I think of a little river stream or a jet out of a fire hose. It's a real thin area of our band segment.
Yeah, and CW, they always say it means continuous wave. It also could mean carrier wave.
Okay, thank you.
What is the approximate bandwidth? And wait a sec. We just did
Yeah, we
this
just
one.
did that for 3,000.
Sorry.
Backed up on that
Alzheimer's.
question.
Sometimes I remember, sometimes I don't. Which of the following operating activities is supported by digital mode software in the WSJT suite? This has a lot of them.
Remember the options?
The options are moon bounce or EME, Earth, Moon, Earth, weak signal propagation beacons or WHISPER, and meteor scatter. But there's also that fun FT8 and FT4. But
Yeah.
this is the correct answer here, what you're looking for, these three.
These are little tweet type transmissions. I think JT8's 13 and 20 characters. So there's little small tweets.
What's their bandwidth? Daniel?
3 kilohertz.
Okay, thanks.
Which of the following best describes broadband hamnet, also referred to as high-speed multimedia network? It is an amateur radio-based data network using commercial Wi-Fi gear with modified firmware.
This
And-
is our amateur internet that goes from Vancouver, BC, to Portland through Spokane and across the nation. We started this plan about 5 years ago. A lot of the areas in the rest of the nation have picked it up, and even different countries have picked up the plan that we have here in Western Washington. This is our own amateur internet tied together on 5.8 gigs from high mountains.
What is FT8? FT8 is a digital mode capable of operating in low signal to noise conditions that transmits on 15-second intervals. And it's
Here I
part of
thought it
the
was one more than FT7. No.
yeah, it's part of the WSJT-X suite.
That is Joe Taylor, who won the Nobel Prize, developed about a dozen different modes of communication with low power and high throughput. He does it by repeating the signal in in this case, in a 15-second interval, and the other person listens for 15 seconds, and they reverse roles, pass it back and forth, and it's about 20 characters long.
Daniel, have you found a one-page blurb that tells you which of the various digital modes are best for what purpose?
Joe Taylor's got some on his website, and I'm not think FL Digi does have on theirs. I can probably put one together
That'd be useful,
On
I
that.
think. It really would.
because he's got some other modes that are good for different things, like meteor scatter.
But there's just a ton of those now, so
There's over 40 different ways we can communicate. Yes.
thanks.
Okay, so we're going to move on to Chapter 5, Section B, Transmitters, Receivers, and Transceivers. Generalized transceiver categories is a mobile, and it's usually a VHF, UHF, FM. Single sideband, usually VHF or VHF, FM. Dual bands, most common are VHF and UHF combos. And then there's all band, which would be an HF with VHF and UHF. And then multi-mode, which would give you VHF, UHF that also has CW, single sideband, and FM modes. And then your good old handy talkies, or HTs. Single band mobile. Single band 2 meter is a good starter radio. Operates from 13.8 volts DC, requires an external power supply or a car battery. They require an external antenna and can be operated either as a mobile or used as a base station. And it's usually limited to frequency modulation or FM and is usually 2 meters or 70 centimeter bands. And it's approximately up to 50 watts output on. In a dual band mobile, it's the same as a single band transceiver but includes additional bands. Most common ones are 2 meter and 70 centimeter bands, but it could also add 6 meters, 222 megahertz, or 1.2 gigahertz bands. and they might have a separate antenna connections for each band or a single connection for a dual band antenna. Multi-mode transceiver has nearly all of the HF rigs are multi-mode. VHF multi-mode operates on FM plus AM, single sideband, and CW modes. Are required for weak signal operation on VHF and UHF, and more features add complexity and the cost. The more flexibility, though, will allow you to explore new modes as you gain experience. Multiband transceivers cover many bands, usually refers to coverage as HF plus VHF and UHF. Also covers all modes. Frequently is 100 watts on HF, some power limitations on the higher bands, usually 25 to 50 watts. Larger units have internal power supplies, and smaller units need external power supply. Handheld transceivers, or HTs. These are small handheld FM units that can be a single band or dual band, and there's even tri-banders, 3 bands. They're limited power, usually about 5 watts or less. And it includes a power or a battery and antenna in one package. Often purchased as a starter rig, but low power limits the range. But these are really good for repeater use. Single, dual, and multi-band versions with increasing cost and complexity. And some HTs can receive out-of-ham bands such as aircraft, commercial broadcast, and are very portable and self-contained. They have internal microphones and speakers, and usually a rubber duck antenna,
Right.
and are battery powered. You can also get extra battery packs, such as a AA cell pack which are useful for emergencies, or you can get a drop-in fast charger. You can get extended antennas for them, and you can also buy external microphones and speakers or a headset. Here's an eye chart with side-by-side comparisons of single band, dual band, multi-mode, multi-band, handhelds, and then the different uses or frequency, agility, function, ease of use, programming. So just a comparison of how things compare side by side. Rig
Hey,
vocab.
Jim, can I stop you there, Jim?
Yep.
Most of the handhelds we get are like from $25 to $500. They're least dual band, 2 meters and 440 or 70 centimeter band, which are our most popular repeater bands. And with those, you can get into the Evergreen Link and talk into Idaho through 4 or 5 different repeaters, or through Oregon into California on those things. If they do have the digital modes, there are 5 different modes you can talk around the world on. Most of them will have IRLP or Echolink on them, so you can talk to different cities across the nation. These are all things you can do with the license you're going for right now, the technician license. All the modes we're talking about, you can use as a technician. And what we have done in our other classes is we've got one of those cheaper radios for $35. We give you an extra long antenna. What they call the rubber duck is about 1/8 of a wave antenna. You actually need about a 1/4 wave antenna to transmit good. And the rubber duck, the longer antenna, is about 19 inches long. It transmits about 4 times longer. And I haven't asked you about this, Jim, but I talked to Dean Kushnow, one of the guys who teaches our other classes, and he says he's got about 6 of those available if some of the students want to buy them. They're $35. He programs those up with local repeaters. So he's got about 80 local repeaters here. So you're ready to go. If you get it off the internet, you got to find someone to program it with the different repeaters that's here. So that's one of the things we're going to be offering to the class. If it's first come, first serve, and I'll try to deliver them to you. And our couple there in Florida will find the frequencies in your neighborhood and program the radio with those frequencies. So when you get it, you'll be operating. When you get licensed, you'll be able to get your license in the database in a day or two or a week or so. And then you'll be want to transmit. This radio that we have will come pre-programmed, so you're ready to get on the nets and like that. So I didn't ask you about that earlier, Jim, but it's one of the things I talked to Dean about Friday, I think it was. And he's got 6 of them currently in town that he's programming and charging up for the class here.
Are those the Baofeng or the Watson?
Those are the Baofengs.
Okay.
The 5, something like that. They're about a 4-watt radio, and the 4-watt, 5 watts, there's not much difference in it actually. But they're a dual band, the 2 meter and the 70 centimeter. They're frequencies that are reprogrammed in there follow the Mike and Key public service booklet. It has a 2-page list of repeaters in there. Those repeaters in the 2 meter and the 440 range are the ones that they program into this radio for you. So it's a neat little deal.
Yep. And that's a good starter radio that if you dip your feet in it and you go, I don't know, I'm, hedging on yes or no, buying something, get that as a starter and play around a little bit. At least it'll get you into the repeaters and other places that, like Daniel said, you can talk to people around the world in different modes. So it's a lot of fun, and that's a good price to if you happen to drop it or lose it, or you're not out a gazillion dollars. So yeah.
The other thing that's good about the inexpensive radios to start with is if you want to get a external mag mount for your car, you can be driving, and with 4 watts, you can work these repeaters as you're driving and really learn a lot and get to know people that way. It's a lot of fun.
Yep.
Now here's like one of those radios here. And this is a shorter antenna, but the other antenna is about that much longer. And it's just the right length for 2 meters and 440 that works really well on it. But this is an Anytone radio here, which has got like 4,000 channels on it. And it does all kinds of things like that. But you don't have to go $200 for a radio. You can go like $35 and maybe $5 shipping, and you'll be up and running on the thing and playing with the big boys. And coming out of this class, you'll be knowledgeable enough. You're not going to be put your foot in your mouth every other time you push the button over here, the push to talk button.
Yep.
So,
Jim, Daniel, would you be able to share the link to the repeater list?
yeah, that's on Mike and Key. Jim, you want to send an email out where that is?
Yeah, I'll actually share it. Let me
Yeah, wonderful.
grab it on
Thank
my
you.
other computer.
Just put a note to do it later. Yeah.
And another question regarding the HT, like if I have a small HT like the Baofeng, and I'm able to listen from a repeater, and I listen from it really clearly, then does it mean that I will also be able to like communicate back with the same power? Because if I have a 8 watts handheld, then it will be
Talk
limited.
about that. There's 4 things you do to program your radio. First, you dial your dial frequency, and that is the frequency that repeater's transmitting on. Then you make sure you have an offset, whether it's plus or minus. That's the frequency you're going to talk back to the repeater on. The third thing is you want your access tone. It's called a PL, a private line, a tone on it. You may want to make sure that you have the correct tone, because there's like 100, 103.5, 127.8, and there's about 40 different tones like that we use on the analog side. So you get the right tone, and then make sure the tone's turned on. So 1, 2, 3, 4, get the dial frequency, make sure your offset's correct, the correct tone, the correct tone's in memory. That's why it's nice to have these radios pre-programmed, and make sure the tone's on. 1, 2, 3, 4. Then when you push the button, the chance of you talking to that repeater, if you can hear it, are almost 99%.
Oh, wow. Okay.
Yeah.
That's cool. Okay, thank you.
Okay, so in the chat, little chat window, I've put the link for the mic and key repeater frequencies. And then the other link is the nets that are on the radio on the different repeaters that you can listen into. Okie dokie. So now getting into the rig vocabulary. We will now go through some jargon and vocabulary specific to receive and transmit functions and controls of the transceiver. Band and frequency selection. Fundamental to all amateur transceivers, you can set the VFO continuously or variable, or by a keypad or a direct entry. Memories can generally store the frequency, the mode, and the filter and similar settings, and alphanumeric labels to help you remember what station that was or repeater you're listening to. Transmitter controls and functions are main tuning display for both the transmit and receive TX and RX. The controls the frequency selection via the variable frequency oscillator or VFO. Frequency can be set with a knob or a keypad or pre-programmed channels. Variable frequency step size, the tuning rate, and the resolution. And rigs can usually store the information for two operating frequencies, a VFO-A and a VFO-B. Mode selectors for both the TX and RX for multi-mode rigs, such as AM, FM, or single sideband. And on single sideband, you have the lower sideband, LSB, or the upper sideband, USB. You can also select CW mode or data for like RTTY or PSK, and could be automatic based on a recognized band plan. Microphone controls have the gain, which controls the transmitter sensitivity to your voice, a speech compressor or a speech processor, which increases the microphone gain at lower sound levels to increase the overall signal strength or the punch. Too much gain or compression, though, can cause problems such as splatter, over deviation, over modulation, and so we have automatic level controls or ALC, which automatically limits speech modulation, reducing transmitter overdrive, but it can cause some speech distortion. And you do not want to have that set for your data modes like the PSK or the RTTY. And it also prevents overdrive to external power amplifier. Microphones and keys, or mic, are hand mics, desk mics. Desk mics usually have preamplified desk mics. And then there's also speaker mics. Or you can have headsets or boom sets. Or you can have an internal mic. And when you speak into the mic, it's generally best if you speak in to across the mic instead of in. Because when you speak into it like this, you're getting a lot of the pop of your vocabulary. So that's why they say speak across, not into the mic.
Okay, Jim.
Yeah.
This is that Bowphone we're talking about, and the microphone is this little hole right over here between the two buttons in here. There's a little hole. That's the microphone. You want to talk about across, like you don't get your breath sounds across it. This is that actual Bullfrog radio I was talking about. You can see the antenna is about as long as my arm, and compare it to the other antenna. So it's quite a bit longer, but it's not too long and it's not too short. It's the length that will work good at 2 meters and 440, the two bands that are the most popular repeater bands. But that's the actual radio right there. And then you got your push to talk button right here, and you got a talk around button here that lets you listen to the input. If someone is not getting the repeater, sometimes you can hear them when a repeater can't, and let you reverse around it. This is going to be your on off, and you change frequency by just pushing the numbers in on the keypad here. And when you hit 6 numbers or 4 numbers, it'll go to that frequency.
Yeah, so when we mail that out, we'll include the link so you can get all of the details of what the radio has and its capabilities.
I'll also give you that Mike and Key public service brochure. Goes with it. It has the list of repeaters on it, so you'll have that with it.
It looks like this if you can see it.
It'll be the 2020.
Yeah, is that high enough or too low or what?
That's
Yep.
good. That's good. Yeah.
Okay.
What we want to do as teachers is give you guys the best experience when you push the talk and get on the radio. Guys want, it's a fun hobby, and we guys want you to have fun starting right off the bat.
All righty. Transmitter off, on and off, or keying. You use the push to talk or PTT, or you can also set up voice operated transmission or VOX. And with VOX, you have some extra controls of VOX gain, a VOX delay, and then anti-VOX. One thing though, be careful with voice operated transmissions. It's very, very sensitive, and there's been stories of people, transmitting things that they shouldn't be transmitting, or even worse, falling asleep and snoring through the transmission. There's usually a key jack on the radios, manually operated transmission or a MOX or a send. That varies with different manufacturers if you have that or not. And it's used for Morse code. You can have a straight key, an electronic keyer and paddle, or a semi-automatic, and they sometimes call them bugs. Receiver controls and functions. We usually have the AF gain, or audio frequency gain, which is also called the volume, controls the audio level to the speaker or the headphones. The RF gain, or radio frequency gain, controls the gain of the receiver's input amplifiers. You also have an attenuator, which reduces the signal at the receiver's input. Receive incremental tuning, or RIT, is a fine tuning, so to speak, and it adjusts the receive frequency independent of the main tuning dial or the main VFO. But it doesn't vary the transmitted frequency. There are, however, transmitters that have a similar function called XIT. You also have automatic gain controls, or AGC, which automatically limits the incoming signals during a signal voice peaks to maintain an even volume. And it keeps the strong signals from blasting into the listener. And there's different time response settings. Fast setting for CW or Morse code, or slow settings for single sideband and AM, and are generally not used for FM because the amplitude is constant. There's squelch controls, which mutes the audio to the speaker when the signal is not present. Used in FM primarily, and when you open it, it allows very weak signals to pass through along with the noise in the background. And if you tighten the squelch, that allows only the strongest signals to pass. Advance the squelch control until the noise just barely disappears. Also open by a monitor or MON control on handhelds. And Daniel had that one that has the little MON on it.
Yeah, it's right here below the push to talk.
Yep.
On the left
On the
side.
side. Yep.
Now, not all these radios have all these features. No, it is simpler, doesn't have all the features. Some of the features are in the menus in here. So it's a simpler radio to learn and pick up. That's why we recommend it for the new people. And some of our more experienced people still use them, so it's not a problem on thing.
Mm-hmm.
So it's, you don't, on all these things we're talking about right now, they're not necessarily in the questions.
Yeah.
We're just going over the whole realm of radios and features that are available to us. There's more that we're not going to cover. And you're only going to be testing on a couple of these things. Go ahead, Jim.
Yep. Filters can be electronic modules or DSP, digital sound processors, which are IF filter, can be used to narrow the width of a signal that is passed and can attenuate adjacent signals. A notch filter is a very narrow filter that can be moved over an interfering signal to attenuate it. There's noise blankers, or NB, which removes signal pulses that are frequently associated with random, naturally generated noise. Can cause problems if strong signals are present. There's noise reduction, or NR, which uses a DSP function to remove noise from a signal. There's a noise limiter, NL, which simply limits the maximum volume of a noise pulse. Preamplifier settings increase sensitivity but can cause an overload. Reception and transmission meter. In transmit, it indicates the output power, or ALC, or other functions as selected by the switch setting. In the receive, it indicates the signal strength. In S units, S1 through S9, with S9 being the strongest. Anything above S9, the meter is calibrated in decibels. For example, S9 plus 10 dB. Receivers can be limited to ham bands or can cover other parts of the spectrum. General coverage receivers cover a wide area of the spectrum and can be used to listen to shortwave listening, or SWL. Data modes. Computer-to-computer communication. Specialized modems have, for specialized modems, you have a terminal node controller, or TNC, or it could be a multiple protocol controller, or an MPC. Or you could use your computer sound card software, which requires a radio interface. Popular digital modes and systems. You have radio teletype, or RTTY, PSK31. I feel a tickle coming on in my throat. Or MFSK, packet radio and PACTOR, or CW, or International Morse Code. Automatic Packet Reporting System, or APRS, and FT8 and related digital modes of communication. And there's also WinLink system. There's error detection in some of these. Yes, error detection is available for packet radio and MFSK, but no error detection on RTTY or PSK31. Error correction, excuse me. Error correction is available for MFSK. Hang on a sec. Oh, and I didn't hit the mute. Sorry about that. Okay, error correction, MFSK has forward error correction, or FEC. Packet radio has checksums and call signs embedded, and it can have retransmission or ARQ. Here's a typical.
ARQ, ARQ is if it detects an error, then it automatically asks for a resend. That's what it does. So it has the sending radio resend a packet that it misses or it doesn't sound right.
Sorry. So here's a typical data station setup. You have your computer set up and then a communication or USB cable to a TNC, terminal node, and then you have your transceiver over here, and it usually has an audio interface that goes in and out of your sound card, and then your computer, usually a COM or a USB to control the radio data. In an internet gateway, there are stations that you can send email through WinLink email servers, and they're connected to the internet, and then your radios can communicate to a station that picks up HF PACTOR. So from your home, you'll have your home set up with a TNC and a computer and your modem, and your transceiver, and you can transmit your email and stuff through HF PACTOR to an HF site or to a VHF site, and you're using RF in this area, and then it deciphers it, puts it to the computer, and sends it to the internet to the other WinLink servers. So this is a great way for emergency communications. If the internet would go down in an area, you could use these WinLink servers to get email sent out of the affected area into other cities or places that still have the internet up and running.
About 10 years ago, we had floods and it flooded the Black Hills and the Centralia like that. Oregon also had those same floods, and the governor was surprised that the amateurs were sending emails out through this system when no one in the rest of the city could, and he could not get it through his government system. So he funded internet gateway systems for all 39 counties in Oregon.
Yep.
And there's no special licenses required for that, right?
No additional licenses besides your amateur license because you're on amateur frequencies. Yes.
Yep. Yeah. So
and this is very similar to what D-Star will do and what our HamWAN amateur internet will do. You'll go into the amateur internet network, and then at different points that's connected to the worldwide network, and you can actually get beyond WinLink and go into a regular email server.
Yep. Yeah, and as technicians, you have the VHF privileges, so you could be doing a VHF packet and send it into the stations, and it'll rebroadcast the email or send it to the internet and email servers that way. And the other fun thing is Automatic Position Reporting System, or APRS. And in the example here, they show an amateur station, K1DAV, and he's traveling, looks like on a freeway there. So it beacons out your position. Let me go back to that. So this is good. The APRS is good for when you have communications where you have like a search and rescue group and they're sending their packets of where they're at, and you can also send pictures and short messages on there. Daniel was mentioning the D-Star. D-Star also has that ability to send and receive pictures.
On the automatic position reporting system, you can send up to 256
Characters.
characters at this point, which is a pretty good sized message at that point. 5 characters per word. You're up there to almost 50 words.
Yep. Okay, question time. If a station is not strong enough to keep the repeater's receiver squelch open, which of the following might allow you to receive the station's signal? So this is when you're working on a repeater and you don't hear.
Well, I can press the monitor button. Yeah.
Yep. Press the monitor, or you can listen to the repeater input frequency and see if you can hear them.
Yeah, that's that second button below, the big button below it on the side of the radio.
What must be considered to determine the minimum current capability needed for a transceiver's power supply? You would want to, all of the above, check the efficiency of the transmitter at full power output, check the receiver and control circuit power and the power supply regulation and its heat dissipation. How might a computer be used as part of an amateur radio station? Last couple of examples we showed. You can use it for logging contacts and contact information. You can send and receive CW or Morse code, and you can use it for generating and decoding the digital signals. Which of the following connections might be used for a voice transceiver and a computer for digital operation? The receive audio, the transmit audio, and the push to talk can be controlled with a computer. How is a computer sound card used when conducting digital communications? The sound card provides the audio to the radio's microphone input, and it converts the received audio into a digital form. What might happen if a transmitter is operated with the microphone gain set too high?
Distortion.
The output signal might become distorted. Which of the following can be used to enter the operating frequency on a modern transceiver? You can use either the keypad or the VFO knob.
This is the keypad, and sometimes the VFO knob is on top of the radio. But it's either here or up here, and sometimes it's on the front. It's a big knob.
What is the purpose of the squelch control on a transceiver? It's used to mute the receiver output noise when no signal is being received.
What you'll normally hear if there's an open squelch, it goes shh. Well, that gets very bothersome after a while. So we turn the squelch up till it disappears. Just after it stops chirping at us, That's where you turn it up to. On this radio here, it's got an internal control 1, 2, 3, 4, 5 or automatic on it in the menu situation. Some actually have a knob you can turn, but it takes away that shh that's on the band all the time.
What is a way to enable quick access to a favorite frequency on your transceiver? Store the frequency in a memory channel. And you'll definitely want that on repeaters because that's a lot of stuff that you would have to remember. The Daniel's 5 steps.
Yeah, 4 steps.
4
This
steps.
has 120 channels here, and we'll program 80 of them. So you have some you can program to your special. And this one has 4,000 channels in 256 group segments in here. This is a $200 radio. This is a $30 radio. So that's generally the difference in these radios. Then we add this longer antenna and program it for you. But the difference in the radios, a lot of times, more expensive, we'll have more channels available in the memory. Plus, sometimes we'll have a digital mode in addition to the regular FM mode.
And sometimes they'll have weather, AM and FM as well.
Well, most of them have that anymore, Robin.
Even the Bafungs?
Yeah, you can
Right.
turn to radio channels. Yeah.
Oh, okay. Thanks.
Which of the following would reduce ignition interference to a receiver? Turn on the noise blanker or the NB button. Which of the following controls could be used if the voice pitch of a single sideband signal seems too high or too low? That is the receiver RIT, or sometimes called the clarifier. What does RIT mean? We just had that one. It means receiver incremental tuning. What is the advantage of having multiple receive bandwidth choices on a multi-mode transceiver? It permits noise or interference reduction by selecting a bandwidth matching the mode.
Remember I said it's kind of like a river channel. If you got a real narrow river channel, you're going to see all the noise on the side of it. But if you have like the Columbia River, which is like FM, it's about a mile wide. You want to look at the whole thing so you don't miss anything. But the Duwamish is only maybe a couple 100-foot wide. You don't need to look at 500 foot of the hillside as well as the river. So you adjust your view so you just see the river and you don't pick up the noise on the side. That's what we're talking about.
Yep. Which of the following is an appropriate receive filter bandwidth to select in order to minimize noise and interference for SSB reception? So another way of thinking is, what's the SSB bandwidth?
It's about 3,000 kilohertz. So anything just below that 2,400 kilohertz is fine.
Which of the following is an appropriate receive filter bandwidth to select for minimizing noise and interference for CW reception?
Remember,
That
that's a
was
fairly narrow
narrow
bandwidth.
one.
So you're looking at the
150.
smallest.
Correct.
What's the answer there? 500.
500.
150 would be fine also, but that's not one of the 4 choices. You can get A, B, C, and D. 500 is the smallest bandwidth there. And so that's the best answer.
Yeah, I don't like these slide decks that don't show the entire question. For some reason, the technician one, they just put the answer.
Yeah.
It would make it easier if they had all of them, I guess. What is the function of automatic gain control, or AGC. AGC is used to keep the received audio relatively consistent.
I was
What is-
always being yelled at because I didn't talk loud enough or close enough to the microphone. So my voice is really quiet. Other people were really loud because they talked really loud. And that's what the AGC does. Someone who talks loud, someone talks soft, they sound the same to you, even though they're quite a bit different coming across the air.
What is meant by the term PTT?
Push to talk.
Push
Yeah,
to
it's-
talk function.
It changes from the receiving, listening mode to the transmitting where you're talking.
What is the function of the SSB/CW-FM switch on a VHF power amplifier? That sets the amplifier for the proper operation in the selected mode.
The SSB has got to be linear, and the sideband or FM does not have to be. So therefore, they can actually put more power on the CW and FM side than it would on the sideband. If they got like an 80-watt linear, you'll go 80 watts on CW and FM, but you may only be doing 60 watts on the SSB side because it has to be a real clean signal to send the audio across.
What device increases low power output from a handheld transceiver? That would be an RF power amplifier. What can you do if you are told your FM handheld or mobile transceiver is over deviating? Talk further away from the microphone.
Yeah, it basically means you're talking too loud. When you deviate, you're deviating from your dial frequency. Remember I said it what goes on both sides of dial frequency? If you get real loud, it goes way far one side, way far the other side, and you're getting into the channels on the side. And someone who's listening just to that channel, it may just actually cut off and may not even be able to hear half your voice if you're over deviating. So you don't want to talk too loud. And that's, you have to have someone else tell you, or you have meters to read your radio on that. So if they say you're over deviating, that means you're distorting and you're starting to chop out. Get back a little bit. It's really easy to do that in an emergency when you're getting excited, or a race when something's going wrong. You start shouting because you're hearing all the noise around you. They say you're over deviating. You have to back away. You got to remember that they're not listening to the noise around you. They're listening to you.
Hey, Daniel, you want to describe the difference between over deviating and over modulating?
Over deviating is over modulating. Deviating is more of an FM term. Over modulating is more of an AM term.
Because I know in the book it's not real clear.
They're pretty close to the same thing. Over modulating is going to be more of an AM term, and
Okay.
over deviating is going to be an FM term. But they'll do the same thing. They'll clip it. When you're over modulating, you'll clip it. And you've heard some of these guitars going, that's over modulating someplace in the circuit.
Yeah.
You're clipping the top of the mountain peaks of the signal. When over deviating, it actually gets out of band and you lose the message when it's out on both, getting to the band on the lower side and the upper side above your band, a channel you're in.
All
You
right,
get into
thanks.
the other two channels, you're actually going to lose it.
Appreciate it.
What name is given to an amateur radio station that is used to connect to other amateur stations to the internet? That was in our
Yeah,
email.
we're going to call that a gateway.
That is called a gateway. Yep.
And that used to be the name of a big computer company back about 15 years ago.
Yeah. Which of the following is a digital communications mode?
You got to pick it up.
Yeah, you gotta pick them up. It's
All of the
Yes.
above.
all of the above. Packet IEEE 802.11 and JT65.
IEEE 802.11, that's Wi-Fi, internet.
What does APRS mean? That was our tracking system, automatic packet reporting system.
Some of our radios will have a GPS built into the radio, and you can turn that function on. Will actually transmit your GPS coordinates. And there's repeaters that use that to pinpoint you on APRS maps. You can get off the internet.
Yeah, and I just noticed Massimo put in the website https aprs.fi, and you can see a big map of all of the radio stations that are checking in.
We
Which
have
in-
a lady at Mike and Key who travels quite a bit in the summertime with her husband in their RV. And if she's going into like St. Louis, she'll pull into the campsite and get onto the local APRS repeater that has that function on it. And she'll key up and leave a message for her sons and daughters. Well, they can either go to the website and they see that she's transmitted from St. Louis, and then they'll go read the message and know that she has arrived safely. And she uses that system when she travels across the nation in the summertime.
Yep. And similarly, there's a APRS app that you could get on your cell phones that can insert APRS packets. And I did what Daniel mentioned, the lady. I actually told my dad, I said, watch on aprs.fi and you'll see where I am at driving towards Colorado. And I had really super good reception because cell phone coverage across the interstates is like nonstop now. And he could see, he goes, oh, I see you stopped at such and such a gas station, or looks like you're eating McDonald's or Wendy's tonight. So he saw exactly where I was at using the automatic packet reporting system through your cell phone app. Which of the following devices is used to provide data to the transmitter when sending automatic position reports from a mobile amateur radio station?
You don't see the answers, but there's going to be a GPS.
Yep. It's a global positioning system receiver.
And like I say, some of our radios have it built in. Sometimes you have to add it.
Yeah. Which of the following is an application of APRS, or automatic packet reporting system, that provides real-time tactical digital communications in conjunction with a map showing the locations of the stations?
We use this on the Ramrod, which is a ride around Mount Rainier in a day route. That's a 150-mile bicycle route. And we can track the leaders or our bike repair vans, the two of them, as they go around the mountain. They're amateurs, so they're into the network.
Yep. What does the abbreviation PSK mean? That is the phase shift keying.
It's a new digital mode that's real similar to Morse code, is continuous wave. Right.
Which of the following best describes DMR, or digital mobile radio? That was a technique for time multiplexing two digital voice signals on a single 12.5 kilohertz repeater channel.
You're going to have an A channel and a B channel. This Anytone is a DMR radio. You get into what they call talk groups, and those people in the talk group can hear you A talk group can be pulled up on maybe 20 different repeaters at one time. We got Washington 1, Washington 2. We've got Seattle ACS has got a couple talk groups. There are hundreds of talk groups out here. We've put in over 55 repeaters in the last 3 years in DMR in Washington.
Yep.
We're actually running 2 C bridges on that, plus some other people in there. It's a network that has been put in very quickly in about 3 years. I've been on about 14 different sites hanging antennas and radios and putting things in. So it's very quickly, it's very quiet. It's a
Yeah.
digital mode. It's using less bandwidth because normally we're running 15, 16 kilohertz, and now we're putting 2 channels in 12 and a half kilohertz.
Is it dependent solely on the internet or non-dependent?
No, you can, it's a standalone repeater, but if we have a backbone of the internet, so it can tie into other repeaters. So like all the repeaters in West Washington can hear the same person if they're on that same talk group.
Okay.
And also you can still do simplex mode with those.
Yes.
Cool.
But yeah, but the repeater that you're accessing will retransmit your signal in its cover area. But the internet allows it to go to the other repeaters in the system that are listening to that talk group.
All right. So if the internet goes down, it's still functional, but just local.
It will be functional because we're using the amateur internet and backing. We're doing a lot of sites, or we're doing what they call hardening and putting
Right.
2 internets in there. Baldy's got 2 internets, so if one internet fails, it'll go back to the other internet. And the ham WAN internet is radio to radio, so it's high mountain peak to high mountain peak, and it's going to go around the regular internet. So
Cool.
we'll have communication. We're going to have communication beyond what a normal person will have. Yes.
Cool.
Yep.
Thanks.
Which of the following may be included in packet transmissions? A checksum which permits error detection, a header that contains the call sign of the station to which the information is being sent, an automatic repeat request in case of an error.
All of these.
All of these above.
A checksum, actually, if you're looking at the message, you got a header that says where it's from, who's going to, the packet number and all that. But the checksum is the number of actual words or word equivalences in the message. And a question mark is considered a word equivalence because it changes the meaning of the statement.
Mhm.
So that's what a checksum is.
What code is used when sending CW in the amateur bands?
There are about 3 different Morse code systems. We use the international Morse code. We don't use the American. There's one other one out there too. We use what's called the international Morse code.
What is an ARQ transmission system? ARQ is a digital scheme whereby receiving station detects an error and sends a request back to the sending station to retransmit the information.
And it's done automatically behind the scenes. And what you see, it takes a little longer for the message to be confirmed that's been sent, but it's an automatic system behind the scenes.
Which of the following could be used to remove the power line noise or ignition noise? That would be the noise blanker.
A noise blanker eliminates repeating noises. Pa, 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 pa. That type of noise will repeat. So it's great on power lines or ignition noise.
What is an electronic keyer? That is a device that assists in manually sending of Morse code.
The Morse code key was initially an up and down, and you guys get carpal tunnel in the wrist from going up and down. Now they'll use paddles, and they'll go one side da 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 da, and the other side dit, 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 dit. So they kind of rock the hand back and forth. It's much easier on the wrist, and that's why we use electronic keys. Electronic key creates the real consistent and time spacing, as well as a da da da. The da is 3 times as long, and then there's a space between it. So electronic key will electronically create that, and then you just rock back and forth which paddle you want. Did it da. You just hit a dot with the one click on the hand. Did it, you hold your thumb down 3 times. It depends which way you want to set them up, but it does it automatically for you. It's much easier to manually send the Morse code with the electronic keyer. It
Yep.
also can be sent with a keyboard and a computer. You just type it in, the computer transmits it to Morse code, you adjust your speed, and then you put the send button that sends it out to the radio.
But that's cheating, Daniel.
That's my way.
I know, but that's cheating. You know it.
I don't care. I cheat then.
Yeah, okay.
And that is the end of module 5B. We have one more module to go.
Yeah.
Close that out.
Are you guys enjoying this? Are you guys?
Yeah.
Are you
Have you guys
falling
gone to
asleep?
Yeah, it's really good.
I'm enjoying it. Yes.
They're watching Super Bowl reruns.
Well, this is really good stuff, guys.
So this last section, we're going to cover power sources, power supplies. Most modern radio equipment runs from 12 volts DC, but the actual preferred voltage is 13.8 volts. Household AC power is 120 volts AC. Power supplies convert 120 volts AC to regulated and filtered DC. If you use a lab type 12 volt supply, be sure it is adjustable to 13.8. Types of power supplies. You can have a linear, which uses iron transformers. They're usually heavier physically, and they do not emit RF, generally immune to strong RF. Or switching, which the electronics are used instead of transformers. They're lightweight and small. However, they can emit RF if not properly filtered. And check product reviews to see how different power supplies are rated.
And they normally have a shorter lifespan.
Yeah. Power supply ratings, voltage and current. Continuous duty tells how much current can be supplied continuously. Intermittent duty shows how much current can be supplied for short surges, such as on voice peaks. And a regulation is how well the power supply maintains a consistent output voltage. Mobile power wiring safety. When you wire up in the cars, the car battery holds a lot of energy, so shorting out a battery could result in fire. Special requirements for safe car wiring. You should put a fuse in both the positive and negative leads and connect the radio's negative lead to the negative terminal of the battery or to the engine block ground strap. Always use grommets or protective sleeves to protect wires as you're feeding it to your radio. And don't assume that all metal in the car is grounded, because modern cars are made up much as plastic as metal nowadays. Batteries create current through a chemical reaction. Individual cells are connected in series or in parallel. Cell chemistry determines the voltage per cell. Different battery types. You have disposable, which are called primary batteries, or rechargeable, which are secondary batteries. And you also have storage batteries. Energy capabilities are rated in ampere hours. Amps times time at a consistent voltage. Battery charging. Some batteries can be recharged and some cannot. Use the proper charger for the battery being charged. Batteries will lose capability or capacity with each cycle. It's best if batteries are maintained fully charged. Overcharging will cause heating and could damage the battery. Lead acid batteries release explosive hydrogen during charging or rapid discharge, so adequate ventilation is required. Automobiles can be good emergency power source by recharging the batteries. A 12-volt lead acid station battery can be recharged by connecting it to an automobile's electrical system. Monitor the battery temperature. Make sure the battery is well ventilated. Handheld transceivers. Battery packs. Packages of several individual rechargeable batteries are connected together. They can be NiCad or nickel cadmium. They can be NiMH, which is nickel metal hydride, or they can be lithium ion or LiION. For emergencies, it's good to have a battery pack that can use disposable batteries such as the AA size. Okay, last set of questions. Why should wiring between the power source and the radio be heavy gauge wire and kept as short as possible? You want to avoid the voltage falling below that needed for the proper operation. The longer you leave that wire, the more voltage drop is going to happen.
And that creates heat.
Yep. Which computer sound card port is connected to the transceiver's headphone or speaker output for operating digital modes? So you end up doing a cross connection on these. Yep, the microphone or the line input. Which of the following conductors provides the lowest impedance to RF signals? That would be a flat strap.
What happens here is the RF signal travels in the surface area. So if you got a solid wire, the RF does not go through the center of the wire. It goes on the edge of the wire. And the higher frequency, it's the closer to the edge it covers. So the flat strap has the most surface area. That's why it has the lowest impedance or resistance to RF signals.
Which of the following could you use to cure distorted audio caused by RF current on the shield of a microphone cable? That would be a ferrite choke.
If you look at a VGA cable for your computer and your videos, you're going to see a lot of times you'll see a rounded little thing at the end of each end of it. It's probably about 1 inch long and about a 1/2 inch diameter. That is the ferrite choke. It stops the RF signals from getting into the computer or speaker and coming out of the computer.
This is also on my power supply brick to keep the
that's it right
noise.
there.
Yep. What is the source of high-pitched whine that varies with the engine speed in a mobile transceiver's receive audio?
Probably the alternator.
The
Yes.
alternator. Where should the negative return connection of a mobile transceiver's power cable be connected?
Mobile, you're in your car. And it should go either to your engine block or to your negative on your battery.
At the battery or engine block ground strap. How much voltage does a mobile transceiver usually require? Car battery.
Yeah.
About 12 volts. Which of the following battery types are rechargeable? Nickel metal hydride, lithium ion, and lead acid or gel cell. Which of the following battery types is not rechargeable? The carbon zinc, the regular AA batteries that are throwaways. What type of circuit controls the amount of voltage from a power supply?
Control, the word is regulator.
Regulators, the answer. Which of the following is a common reason to use shielded wire? A shielded wire is used to prevent the unwanted signals to or from the wire.
Okay, Jim, at this point is where I normally say, what is an antenna? And the answer is any wire can be an antenna. So therefore, in order to stop that wire from being antenna, you want to shield it and then ground the shield.
Oh, and that's the end of the module.
Any
Perfect
wire
timing.
is an antenna. Even your toaster is regulated by the FCC because it has a wire in there that it uses for a heating element. Whenever you put power to any kind of electronic device, it has wires in it, and those become antennas to transmit or to receive signals. So then you got to put those ferrite chokes in there to stop it, or maybe a capacitor filter in there to filter it off. There's things you can do to filter that signal out, but FCC regulates everything, and that's why you can't sell electronic device in the United States unless the FCC has given its stamp of approval on it. And typically that is going to be a Part 15 device, which has to accept interference and cannot cause interference. Now, these amateur radios we're talking about, they're Part 97 devices. We can cause interference. We shouldn't cause harmful interference. There's cases we can legally because we're authorized to be on the band. But if we cause interference, because we have so many frequencies, like 22 billion frequencies, we generally move. It's polite for us to move because we got areas to go to. We don't have to be on this channel. But this is a Part 97 device, and we have the right to cause interference, but not necessarily intentionally. We don't do it intentionally. Any wires and antenna.
Does that mean if you have wireframe glasses, you have an antenna on your head?
Yes, but watch frequency you're listening to. What channel you're listening to.
Okay.
If you got a radio signal in your mouth, it's because of your teeth. Yeah. The length of the wire, Robin, at this point, the length of the wire tells you what frequency you're going to be listening to.
So I have 2 loop antennas here. Okay, I got it.
Yeah. But they're at gigahertz signals.
Yeah. So do we have any questions, any thoughts on this section? The next chapter is communicating with other hams and is 24 pages of reading. And the videos are pretty short. There's a little bit longer video for public service and for satellite operating, but it shouldn't be very long at all.
The amateurs produce the communication channels for the Ramrod race, and that's called a public service event where we're supporting parades or races, 5K races or whatever for data and safety support. We're out there mainly for safety. We've done a lot of things in the last 5 years to make it a safer race for the bicycle people, or safer event, because it's not necessarily a race, a safer event for the bicycle people. If they got problems, we can tell them where the mobile repairs service is. They get kind of free repair service along the trail, and there's 2 vans that go around and do that. We can tell them how long, and tell the guy to hurry up to get over there, because a lot of times they're sitting around waiting and doing nothing at the stations. We can get the food moved around, water moved around, people moved around. If someone has an accident, we can get help right away, and we've done that year after year on the different things. So yeah, we're out there for public safety and support, and we do the communication on it. And it's a lot of fun being out there for 2 to 4 hours on these things.
Yeah, and the other cool thing is when we're not in COVID and they have the Blue Angels and the jet boat races, you get free admission when you volunteer a lot of times to go and you get to, some of them are in the pits, and yeah, it can be a lot of fun. Or you can be right up in the front in a parade. It's a lot of fun.
Yeah,
And
I get
And there's
free
some
pit
public,
passes.
yeah, there's some public services that wouldn't be even, they couldn't run them unless there was proper communication provided by the amateurs. So.
Yeah.
Okay. If there's no other questions or comments, I'm going to go ahead and stop the recording.